We'll start it again. Okay, so keep those things in mind, and just a little bit about notation. So you know how this notation, sine to the minus 1, the inverse notation for a function, can get confused with the reciprocal notation, 1 over sine, which is cosecant? To keep us from doing that kind of confusion, you will also see this as your notation. Sine inverse x might be written, and in your textbook it is, as arc sine x. So it's nothing new that you didn't already know. It's just a word you haven't used before. And arc cos and arc tan mean correspondingly the same things. Okay, so our sine graph, we have a graph there on the back board. It's not one-to-one, is it? It's a function, but it's not a one-to-one function. It doesn't pass a horizontal line test. So that odd function back there is failing our horizontal line test, which is why you would get how many solutions if you did a sine inverse. Well, your graph would look like that. So picture that sine graph tipped on its side. It's going to look like that. That's not a function. So what we do is we restrict the domain. Okay, so a quick sketch of your sine graph right here. Center top, center bottom, back to the center, and I'm actually going to do 2 rotations. That is from negative 2 pi to positive 2 pi. And pi by 2 and negative pi by 2. Okay, so this sine graph, in order to keep it one-to-one, we just look at a little part of it. So part of it that's going to give us the entire range from negative 1 to positive 1. And we want the entire range out of it, but we want to restrict the domain. So it gets restricted from negative pi by 2 to positive pi by 2. So in Math 12, I told you when you want a reference angle, remember if it wasn't one of the special ones and we had to inverse sine it on our calculator, I said your reference angle always positive, and then we reinterpreted it back in terms of our bow tie that we had drawn. If you're just using your graphing calculator, you can get a negative answer. Then it's complicated because you have to remember that that is referring to something in the 4th quadrant where your sign is negative. So it's really giving you answers in the 1st and 4th quadrant when you use the inverse sine button on your calculator. And from there you have to interpret what the reference angle is and figure out what it is you want. Okay? So domain restrictions on sine inverse, you need to know what they are. Negative pi by 2 to positive pi by 2. And of course, the range, so in order for us to say sine inverse x equals y, it means the sine of y is equal to x, and we restricted the x between negative pi by 2 and positive pi by 2. So our domain for sine is all reals, which we just restricted. And our range was from negative 1 to positive 1. When we take the inverse, our domain will be from negative 1 to positive 1. And our range will be from negative pi by 2 to positive pi by 2. So for sine inverse, then the number you put in has to be between negative 1 and 1, and the number you get out will be an angle in either the 1st or the 4th quadrant. And then you're going to have to interpret that answer in context. Okay. Let me ask you a question. What is sine inverse of the sine of 30 degrees. Say it out loud. 30 degrees. Okay, what is the sine of the sine inverse of a half? What is it? 1/2. Okay, well, here's a trick question. What is sine of sine inverse of 30? If you don't know the answer, put it in your calculator. Is it working for you? No, you're getting an error. Okay, how come? Because it's not in the domain of the inverse function. Okay, so don't just sloppy look at this and say the answer is 30. This does not exist. Why not? Because we tried to put something that is not in the domain of our composite function. We've got a composition here. Composition works from the inside out. And if you break the inside function, you're never going to get here to the outside function.